Rob?
All right, Jennifer, thank you. 7:25, time for part 2 of our Chemist Corner segment. We are back with Jesse Miller from the U of I and some more liquid nitrogen.
Yeah, there's some liquid nitrogen here, but inside the liquid nitrogen, this morning I went into the lab kind of early, about 4 o'clock this morning, and I distilled some oxygen.
Oh, okay.
And I use liquid nitrogen because it's colder than liquid oxygen. Not much colder, but a little bit colder. And you can see liquid oxygen is kind of pretty. It's blue. Mm-hmm. It's a nice blue color, which, like nitrogen, is clear.
Okay.
You know, and 78% of the air is nitrogen, but 21% of it is oxygen, and the other 1% is like argon and some other things. So I thought it might be kind of interesting. You don't get to see liquid oxygen very often.
No, you don't. That's
and
very
this
cool.
is, you know, you don't want to smoke around this, that's for sure.
Sure.
So it has a couple of interesting properties that I was going to show you. And if you just hold this for a second there. I'm going to cool this magnet down. Turns out that liquid oxygen is what we call paramagnetic. It has unpaired electrons, and so it will stick to the magnet. This is liquid nitrogen. I'm just using it to cool down the magnet. But as you can see, careful here.
Sure.
As you can see, it doesn't stick to the inside of the
No.
2 poles there. It just kind of runs over it.
Right.
But if we pour some of the liquid oxygen onto the 2 poles here, you can see.
Oh, it stays in between?
Yeah, it stays in between there because it's magnetic. There we go.
Wow.
That's pretty cool.
That
you don't get to see that very often.
No, never. That's
so,
very cool.
But, you know, playing with liquid oxygen wouldn't be complete unless we, like, burn some.
Sure.
And combustion, you know, oxygen is necessary for combustion. Mm-hmm. And let me just pour it in this dish here. And the more oxygen you have, the better it combusts. And so I have quite a bit of oxygen here. And what we're going to do, my favorite particular junk food is Cheetos.
Cheetos?
That's right. It's messy, but you gotta love them.
It's all right.
And we talked about calorie content earlier and how much energy is in it. We're going to see exactly how much energy, a little bit more visually, with the Cheetos. I'm going to get this started to burn here just a little bit. It doesn't burn all that great, but once I throw it in there, that's pretty cool.
Yeah.
Don't look at it too close.
Yeah, I just did that. It's like a welding torch. Now, why does this happen again?
Well, it's just we've just sped up the combustion. Basically, we've added so much oxygen to it that it's burning faster.
Okay.
Okay. Burning is just oxidation of whatever it is that you're oxidizing. In this case, the Cheetos. Shoot. Anyway, so when we have liquid oxygen, that's a lot of oxygen to be combining with the Cheetos, the burning Cheetos, and the flame, it just flames up. And like I said, it's got a lot of energy in it.
Right. And we're talking about fire here and combustion, and there's a lot of different kinds of fires that you're working on for next week.
That's right. Next week I was going to show the different types of fires that we have, classifications, and also the different types of fire extinguishers used to put those types of fires out. Okay. Because you have water and CO2, and they all work chemically differently to put out the fires. Okay. And we're going to go to the fire department and play a little bit. Another reason why firefighter is a very dangerous job. Oh, it certainly is. Got to be a smart guy to do that. All right, well, speaking of smart guys, he's our resident chemist, Jesse Miller from the U of I. Thanks for being here. Appreciate your time.